Hello everyone, Carson here back on Sudoku on New York Times. Today is August 23rd, 2024. Let's start today's hard Sudoku. Okay, I see that in block 2, there are 3 open cells left. That immediately draws my attention. I want to think about the missing digits of block 2. Uh, the missing digits are 1, 3, and 7, where these 2 open cells see the 7 in column 6. So the digit 7 is forced into this cell, leaving a 1-3 pair in block 2. Alright, talking about 7s, I see that these 7s points left. This 2 points down and this 2 points left. So in block 7, the digit 2 is forced into this cell. These 2's points up and this cell sees another 2. These 2's force the digit 2 into one of these 2 cells in block 5. These 2's point right. This 6 points down. So in block 7, the digit 6 is forced into one of these 2 cells, and these 2 cells form a 6-7 pair. Because in block 7, the digits 6 and 7 are still missing, and these 2 open cells cannot contain 6 or 7. So both 6 and 7 are forced into one of these 2 cells, and they share the same 2 cells. So in block 7, in order to fit both 6 and 7, we have to fit these 2 digits into these 2 cells, or in other words, these 2 open cells are reserved for 6 and 7. So we can eliminate all other digits from these 2 cells because it's a part of the 6-7 pair. It can't contain anything else apart from 6 or 7. So that makes the other 2 cells in block 7 a 1-4 pair. So 4's here, and this 4 points up. With these 4's, they force the digit 4 into this cell in block 1. This 4 points down, and this 4 points right. So in block 6, the digit 4 is forced into column 8, and then these 4's point down. Now, I see that this pattern formed by the digit 4, but I'll explain it in a much simpler way. In row 8, 4 cannot go into the 6-7 pair. This cell sees 4, this cell sees 4, and this cell sees the 4 from block 6. And 4 is still a missing digit of row 8. So in row 8, the digit 4 is forced into this cell, because all other open cells in the same row cannot contain 4. But we still had to fit 4 in one of the cells, so it must go here. And then these 4's force the digit 4 into one of these 2 cells in block 5. Okay, why I said that the pattern of these 4's immediately drew my attention is that no matter if 4 goes like this or in the other way, all of these open cells in block 8 that are in rows 7 and 9 see these 4's. So these 4 open cells cannot contain 4 because it sees one of them on both sides. So in block 8, 4 must go into one of these 2 cells, but at the same time, this cell also sees 4. So 4 is forced into this cell. 2 ways to see it, both have the same outcome. It depends on which one you see first or which one you like to use more. It's completely up to you. They have the same outcome. So yeah. Okay. This 8 points right, and this 8 points down. So in block 8, the digit 8 is forced into this cell. This 9 points down. So in block 8, the digit 9 is forced into row 9, and then these 9's point right. Oh, actually, these 2 cells form a 1-9 pair to make up row 8. Okay, these 5's point right, and these 2 cells form a 2-5 pair, because in block 9, the digits 2 and 5 are missing, and because of these 2's and 5's, none of these 5 open cells can contain 2 or 5. So these 2 digits can only go into these 2 cells, and they share the same 2 cells. So in order to fit both 2 and 5 into block 9, they have to go into these 2 cells, or in other words, these 2 open cells are reserved for 2 and 5. So I can eliminate all other digits apart from 2 and 5 from these 2 cells. So after 4 is eliminated from this 2-5 pair, I can then force the digit 4 into this cell in block 9, which helps place the 1 and 4. Okay, these 2 cells form a pair of 6 and 8. Because in block 9, we have 6 open cells left. We have a 2-5 pair. We have another pair of 1 and 9. So that makes the remaining 2 open cells a pair also. So the missing digits are 6 and 8, but this cell sees 8. So I can actually place these 2 digits like so, and this cell is a 3 to complete row 7. Down here we got 1, 6, and 9 as the missing digits of block 8. This cell sees 6, this cell sees 9, and this cell sees 1. So 1, 6, 9, like these are the possible places for 1, 6, and 9 to go. In column 2, 3, 7, and 8 are the missing digits. 3, 7, 8. This cell sees 8, so it's 3 or 7. This cell sees 7, so it's 3 or 8. Okay, in row 2, 1, 3, 6, and 7 are the missing digits. But this cell sees 1, 3, and 6. So this must be a 7. If that was too quick for you, I'll break it down slowly. Again, this cell sees 1, 2, 3, 4, 5, 6, 8, and 9. So the only digit that this cell does not see is 7. So 7 must go in the cell. Because we don't want any empty cells in Sudoku, so we have to fit at least 1 digit into that. I mean, we can't leave a cell that are not possible for any digits to be in. So if this cell cannot contain 8 digits, it must be the last remaining one. So 7 must go into this cell because it's the only digit that can go in this cell. No other digits can go into the cell. So 7 must. Okay. That makes the other 3 open cells in this row containing 1, 3, and 7. This cell sees a 7. No, wait, 1, 3, or 6. What am I thinking? Sorry. Okay, I just placed the 7, so these 3 open cells contain 1, 3, and 6. Okay. Where this cell sees 1 and 6. So actually, I should have eliminated 7 from this cell and made this a 3 immediately. This is an 8 and this is a 7. 3s cannot go here. These 8s force the digit 8 into this cell in block 6. This 7 points up and this 7 points right. So in block 6, the digit 7 is forced into this cell, and all of these 7s force the digit 7 into this cell in block 5. These 7s point left. Okay, I see that 3 and 9 here points up. And since both 3 and 9 are still missing from block 4, these 2 cells over here form a 3-9 pair and eliminates all other digits from these 2 cells. It's the same concept as all other pairs you've seen in this Sudoku puzzle, so I'm not going to explain that again, but just know that because these 3 open cells see 3 and 9, and it only leaves 2 open cells for these 2 digits, these 2 cells then form a 3-9 pair, eliminating all other digits, apart from 3 and 9, from these 2 cells. Okay, that makes these three open cells a triple of 1, 5, and 8 to make a block 4. This cell sees an 8, this cell sees a 1. Okay, in column 9, 2, 5, and 9 are the missing digits. This cell sees 9, and this cell also sees 9. So in column 9, the digit 9 is forced into this cell, which leaves 2 and 5 as the missing digits of column 9. In column 4, 1, 3, and 9 are the missing digits. This cell sees 1, so it can only contain either 3 or 9. And now, in row 5, there are 2 open cells that can only contain the digits 3 and 9. The keyword is only. In row 5, in this case, when you have 2 open cells that can only contain 2 certain digits, they must be kept into those 2 cells, because nothing else can go into these 2 cells. No other digits can go into these 2 cells because, well, it sees all of those digits. So because only 3 and 9 can go into these 2 cells, we have to keep both 3 and 9 into these 2 cells. And as a result, 3 and 9 are eliminated from all other open cells in the same row. Another way to say this is that because only 3 and 9 can go into these 2 cells, it means that no other digits can go into these 2 cells. So where are all other digits? They go into the other open cells. The missing digits of row 5 cannot go into these 2 cells, so they have to go into the other open cells. So that's why we have to keep 3 and 9 into these 2 cells. And therefore, 3s and 9s are eliminated from all other open cells in the same row. So that's the other way a pair or triple would work. So bear in mind. So these 2 cells cannot contain 9 because of what I just said. So in block 6, the digit 9 is forced into column 8. These 2 cells these 2 cells cannot contain 9 because 9 has to be kept in one of these 2 cells for this row. So 9 must go into, well, it can't go into row 5 of block 6, so it must go into one of these 2 cells where both are in column 8. So 9 is eliminated from this cell because it now sees the 9 from here. So this makes this a 1 and this a 9. These ones point up to force the digit 1 into this cell in block 3, which makes this cell a 3 and this cell a 6. This cell a 1, a 1. Okay, this 3 points right and this 3 points up. So in block 3, the digit 3 is forced into this cell. This is 2 or 5 to make up this block. This is also 2 or 5 for this column. These 6s force the digit 6 into one of these 2 cells in block 5. Okay, so this cell is a 9 because it sees every other digit. The cell sees 1, 2, 3, 4, 5, 6, 7, and 8. So the only digit that this cell does not see is 9, so 9 has to go into this cell. Again, because in Sudoku, we cannot have any empty cells. So if no other digit apart from 9 can go into this cell, we must fit a 9. Because no other digits can go into this cell. And we don't want an empty cell. So we have to put a 9 into this cell. Which points down and makes this a 6, this a 1, and this a 9. This cell now, cannot contain a 9. 9 is eliminated from these two cells. Making this a 3, this a 9, this a 3, and this a 1. What next? Okay, these 9s force the digit 9 into this cell in block 6. All 9s are placed. After 9 occupy this cell, I can immediately force the digit 4 into this cell in block 6. This cell is 2 or 5 to make up this block. This is one, well, these ones point left to force the digit 1 into this cell in block 4. 2 or 5 are the missing digits of row 6. Okay, these 4s force the digit 4 into this cell in block 5. This cell is for 5 or 8 to make up row 4, but this cell sees an 8. So I can actually place these two digits like so. This 5 gets the whole right-hand side done. This cell is an 8 to make up this column. This is a 2 and this is a 6 for these two rows. And up here we got 2 is eliminated from from this cell. So in block 1, the digit 2 is forced into this cell, which makes this a 7. And the Sudoku puzzle is complete. Alright, I finished today's New York Times Hard Sudoku in about 17 minutes. Okay, I would say this puzzle is not too difficult. I mean, it's the right difficulty. If you spot all the pairs and triples, and the naked singles pretty quickly, you're gonna have no problem. Like, you're gonna find this very straightforward if you do so. So I'll go over the key spots as a summary. So, first of all, getting most of the info from block 2 was quite useful. And then, down here, there was the 6-7 pair in block 7, the 6-7 pair and the 1-4 pair here. Okay, and then moving on to block 9, here, this block, there was the 2-5 pair, 1-9 pair, and placing the 6 and 8. Okay, and then, which cell was the single? I forgot. Which one was the first one? It might be this 4 right here. I don't remember, but that was a single. And I believe that this 6 up here, no, this 7 up here, yeah. In row 2, column 9. In row 2, column 9, this 7 was a single. And I forgot which one the other one was, but I forgot. Sorry. Later on, there was the 3-9 pair in block 4, the 3-9 pair in block 4, and then another 3-9 pair, but this time in row 5, and it works in a different way than other pairs. So yeah, the 3-9 pair in row 5. And then after that, I feel like, after you spot that, the Sudoku puzzle could be completed, really quickly after that. So these were the key spots. Hopefully this video helped. Even if you have any other questions or difficulties, feel free to leave them in the comments down below. I'll be glad to reply you. Today is August 23rd, 2024. See you all in tomorrow's New York Times Hard Sudoku Solve. Bye!